What's up, pre-calculus students? Let's do the 4.6 homework. I love this lesson. I love solving equations, and I have to answer the phone real quick. All right, I'm back. Solving equations with logs, exponential equations, where you really have to understand logarithms, understand log properties, isolating x. In this situation, like I'm getting rid of the natural log, the log base e, using e to a power of both sides. I know some of you like to rewrite things. That's fine. Like, go ahead and do it. We'll see later with inequalities. Doesn't work out. The last thing we got to also pay attention to are potential extraneous solutions. When I take e to the power of everything, I make everything positive, which means I might get like solutions that we think are correct, but ultimately they are not in the domain of the log function. What do I mean by the domain of the log function? You can only plug in x values that are bigger than 0 into a log. It's the whole idea of like exponential functions. The y values can only be positive, which means we can only plug in your inputs. Your outputs are always positive. You can only have inputs that are positive for logarithms. So we're going to get answers, and we're going to have to check to make sure they work in the original equation. And these both do. If I plug in -7, square it, 49 minus 48 is 1. The natural log of 1 is 0. 7 squared 49 minus 48 is the natural log of 1, which is 0. Just reminders for all of these questions, check your answers. Make sure they work. Okay, so this one, like, very important. We got to get rid of the log. I'm going to take e to the power of both sides. I get x squared minus x plus 13 equals e to the 0, which is 1. I'm going to subtract 1 from both sides. I'm going to factor this, x minus 4, x plus 3. I will get solutions for x. However, we are going to be careful. I'm going to go back and check. In the original equation, if I plug in 4, I get 16 minus 4 is 12 plus 13. That's fine. Did I make a mistake? Positive 12. Can't be -4 and 3. I don't think this can be factored. Shoot. This is why we check. This question should have a negative here. Should be -11, honestly. Who made this question? Probably me. Probably made a mistake here. Oh, my bad. Anyways, it should be like that. Should give you x minus 4, x plus 3. Sure, if this was a -11. Should give you x equals 4, comma, x equals -3. Plugging in, it should work out where it's the natural log of 1, which gives us 0. I get 16 minus 4, which is 12, minus 11, which is 1. Good. Okay, now let's look at this one. -3 squared is 9. Minus -3 is 12 minus, okay, this works out too. Okay, so these are both fine. This guy, what's very important to do whenever you have multiple logarithms, like this, this. So understand what you can't do. You could do it, just like you're not going to do it correctly, you students. What you can't do is be like, oh, let's just take e to the power of both sides. Okay? And it's like, oh, the logs go away. I have x squared minus x equals e to the 9th. Wrong. Okay? Oh, let's take 2 to the power of both sides. And the logs just go away. Wrong. Wrong. Okay? Wrong. Don't do this. Okay? What we could do this, but I'm not going to show you like how you could then manipulate it using exponent rules and then how like that exponent rule and the log property works out with each other. What we have to understand is To get rid of a log, we just need one log. We can't get rid of multiple logs separated by addition. We are going to use log properties. Okay, so we remember log of x squared minus log of x. When you're subtracting, it's the same as like dividing the values that you're taking the log of. I'm going to go ahead and simplify this to be natural log x equals 9. I will then get rid of the natural log with e to a power. X equals e to the ninth. Let's see, the natural log of e to the ninth squared is 18, because 9 squared, you multiply those powers, you don't take the power to the power. Minus the natural log of e to the ninth is minus 9, works out. Same thing with this guy. I would rewrite this as x cubed over x. I would rewrite this as x squared. I would take 2 to the power of both sides to get rid of the log base 2. This is something that I'm trying to get through to all of you. A lot of you are like, oh, it just makes sense that I do it this other way. It's like, all right, like that's how you learned it. I don't know if it really makes sense to you, but like they're inverses, they undo each other. This is what we're trying to say, like 2 to the power will undo a log base 2. It's like squaring a square root. So you get x squared equals 2 to the fourth, 2, 4, 8, 16. We get x equals plus or minus 4. Now, we check our answers. If I plugged in -4, I'd have the log base 2 of -4. Guess what, team? You are not allowed to plug in a negative value into a logarithm. Right here, I can see that if I plugged in -4, it'd be the log base 2 of -4. What we have is a situation where we have an extraneous solution. What we want you to do is identify the extraneous solution, cross it off. You know that like it was a solution to like the previous equation where the logs were gone, but it ends up being extraneous. It's a fake solution because of the domain, the x values you can plug into the log. Okay, so we want you to get it and then get rid of it. Like this is the most common one that students will make mistakes on. They will think that you can take the 5 to the power of both sides and you just get x minus 3 plus x plus 1 equals x minus 3. Wrong. You can't do this. You could do this step of taking both sides to the power of 5, but then you'd have to use exponent properties to simplify this idea with the sum and the exponent. I'm not going to do it. I'm not going to get into it because it's like, it's just using log properties that we know. If you are summing up very similar to x to the 2 plus 3, you can write it as a product of x minus 3 times the x plus 1. I'm going to keep this as log base 5 of x minus 3. That's fine. Again, now that we have a log on both sides, we can go ahead and multiply. We can get rid of the log base 5. Now it happens to go away on both sides, giving me x squared minus 2x minus 3 equals x minus 3. I kind of need more space here. I'm going to put everything on one side, set things equal to 0. I'll zoom in for the next question. Giving me x squared minus 3x plus 0, because I add 3 to both sides. Giving me x minus 3. Giving me x equals 0, comma 3. Guess what? Both of these don't work. What? Yeah, both of these are extraneous. This is kind of like a fake out problem, poorly designed problem that we'll have to change in the future. Why? I'll show you. I didn't even notice it. So we got to change B, we got to change E. I'm going to just subtract log base 5 of x minus 3 from both sides. What do I get? Log base 5 of x plus 1 equals 0. We get 5 to the power, x plus 1 equals 1, x equals 0 Okay, well, I can't plug in 0 into the original equations because I'd have the log base 5 of -3. So, like, there are no solutions. Oh, boy. Nah, you'll be okay. All right, let's see if this one works. Log base 3 of x plus 8 plus log base 3 of x. Can't just take 3 to the power of both sides. I'd use log properties to rewrite this as log base 3 of. I'm going to go ahead and multiply the x by the x plus 8, x squared plus 8x equals 2. I will now take 3 to the power of both sides to get rid of the log base 3. I get x squared plus 8x equals 3 squared, which is 9. That's x squared plus 8x minus 9 equals 0. That is x plus 9x minus 1 equals 0. I get x equals -9 and x equals 1. I cannot plug in -9 into the logarithm. This is an extraneous solution. I can plug in 1. I get the log base 3 of 9, which is 2, and the log base 3 of 1, which is 0. We would want you to do all of this work to identify the extraneous solution, not like guess and check with x values. That's not what we want you to do. That's not how the questions will be asked. Kind of same deal with this guy as the one previous. Hopefully it works out. You can't just take 4 to the power of both sides. You need to isolate the logs. We get x squared plus 2x equals log base 4 of 3. Now, what I'm doing, what is important to be done, especially when we go to h, to remember, like, things don't just disappear. You're taking 4 to the power of both sides to get rid of the log base 4. We get x squared plus 2x equals 3. We get x squared plus 2x minus 3 equals 0. We have x plus 3x minus 1. We get x equals -3 comma 1. I can't plug in -3. I can plug in 1. There's my solution. Won't always be 1. Multiple ways to do this problem. I'll show you both. We could combine our logarithms using log properties. We get x squared plus 8x plus 16 equals 2. I get rid of the log base 2 by taking 2 to the power. Happens that 2 to the power of 2 is the same as 2 times 2, but make sure you understand what is the process you're doing here. You're taking 2 to the power of 2. I'm going to subtract. And I get that. Get x plus 6, x plus 2. Get x equals -6 and -2. I can plug in -2, that's fine. I can't plug in -6, that's extraneous. That's one way to do it. Let me show you another way. You're adding two of the same logs. You could write this as 2 of the log base 2 of x plus 4 equals 2. I could divide by 2. Give me log base 2 of x plus 4. You could also like bring that 2 up to be a power. But I'm going to divide by 2. I'm going to take 2 to the power of both sides. It gives me x plus 4 equals 2. X equals -2. Like, boom. We don't get the extraneous solution if we do this. Just get the right answer for this type of problem. We'd be okay with it. Okay. This one. Get rid of the natural log with an e to the power. We get x squared plus 5x plus 5 equals 1. We get x squared plus 5x plus 4 equals 0. I get x plus 4x plus 1 equals 0. I get x equals -4 and -1. If I plug in -1, I get 1 plus -5 plus 5, which gives me the natural log of 1. That's good. If I plug in -4, I get 16 minus 20 plus 5. These are both work. There's no extraneous solutions here. Yeah, what can you do here? Can you bring the 2 up? Sure, you could if you wanted to, but like you could also divide both sides by 2, which is what I'm going to do. Then I'm going to get rid of the log base 5 with a 5 to a power. Subtract the 5. Divide, get 26, which is the same as 10 thirds, which works. I like how we're taking 5 to the power. We get a number that's not 10, it's 25. Cool. All right, to some harder questions. These exponential questions, and then we're going to get into inequalities. I wish we had some simpler inequalities just to show you um, how sometimes moving things around will get you the wrong answers with inequalities. But I digress. Let's do these. Now, you'll see there are multiple ways to do this, but take advantage of what's like obvious to you. If there are things that are obvious, use it. Like I see 2 to the 2x minus 3, I see 8 to the x. Now in the future, like next page, first step is to take the natural log of both sides. And I'll come back to this question. I'll do it where I just like start by taking the natural log of both sides or the log base 10 of both sides, but natural log less work. But I noticed that 8 right here is a power of 2. So my first step here is to rewrite 8 as 2 cubed. So, understanding 8 to the x can be written as 2 to the 3x. Now, yes, like things kind of disappear on you, but you're taking the log base 2 of both sides so that the 2 goes away and you just have the exponent. This is important to do so that we don't make mistakes with it in the future. I get x equals negative 3 after subtracting 2x. It'll work out. 2 to the negative 9 is the same as 8 to the negative third. Yep. Same with this. We kind of notice 81 is the same as 3 to 3, 9, 27, 81, 3 to the fourth. It's kind of like we get things down to the same root, same base, so that we can take the log base 3 of both sides. Many of you won't do this. Many of you will be like, well, if it's the base, then like the inputs have to be I get 4x plus 7 equals 4x. I get no solutions, which is possible. You'll get 0 equals 7. Not true. No solutions. I'm okay with this question having no solutions as its answer. If I change this to 3x, we'd be able to find a solution. Maybe I will do that in the future. I gotta write down these problems. First, change 1b. I'm gonna tell you all to change 1b before we get into our homework. 1e is not a good one. We're gonna try to change that one. We're gonna change 2b. Moving on. Okay. There are multiple ways to do this one. Okay? I'll show you multiple ways. My first instincts when I see this problem is divide by e to the x. Now, we never want to divide by x. It potentially can remove a solution whenever you divide by something with a variable and that goes away. But I get e to the 4x equals 9 in this situation. You can either write this as e to the fourth e to the x and take the log base e to the fourth of both sides, or you can take the natural log of both sides to start with and then divide by 4. Cool. Or, and you'll see this later, we could start with e to the 5x equals 9 e to the x, and I can literally just take the natural log of both sides just to start. Now, why would I do that? Well, the left side, we know the natural log of e to the 5x. The natural log and the e will undo each other, just leaves us with the 5x. Once my cursor. On the right side, I can't say this is the natural log of 9 times x. I could use a logarithmic property that says if you have a sum, if you have a product, you can write it as a sum. giving me natural log 9 plus the natural log e to the x. Now the natural log of e to the x is just 1. So I get natural log 9 plus 1. Now if I divided everything by 5, I get this. And it's like, well, Mr. Messenger, these look like two different answers. You would think, but they're the same. Just got to figure out how they're the same. I could write one as e. I can rewrite this as the natural log of 9e over 5. I'm not seeing how they're the same. I'm just going to check. I'm pretty sure they're the same. But I'm not seeing how they're the same. You know what I mean? Oh, they're not the same. What did I mess up on? Oh, stupid, Mr. Messner. My bad. They're the same. Yeah, this is when it's like, yeah, when we do these problems the first time, we'll make mistakes. Natural log of e to the x is not 1. The natural log of e to the x is x. Subtract an x. Boom, look, we're getting the same answer. 4x equals the natural log of 9. X equals the natural log of 9 over 4. So two different ways. You're going to see a little bit later that sometimes the first step for these exponential equations is to take the natural log of both sides. Probably a safer step is to actually do that. But it does work out if you divide. So doing it two ways. Dividing by e to the x, you'll get e to the 3x using exponent rules. E to the 4x divided by e to the x, you subtract the exponents when you're dividing, exponent rules. Then take the natural log of both sides, get 3x equals the natural log of 24. You get the natural log of 24 over 3. Or natural log both sides, natural log e to the 4x equals 20, natural log of 24 e to the x. Use a log property to split up 24 times e to the x, ln 24 times plus ln e to the x. We get 4x equals, and again, these are things that like I've done so much that I've seen them and I've done them. If you don't actually do these problems, they're tough. You know, you won't see it. It's like, oh, this is when I can do this, and this is when I'm going to do that. So like, you have to practice. All right, so cool. These are my favorite questions. They're like fun questions. You're going to get some crazy values. 4 to a power equals 3 to a power plus 1. What is x? Neither of these can be written as a base of the other. You can't write 4 as 3 to a power easily. You can't write 3 as 4 to a power easily. Best thing to do is to utilize a logarithm and use logarithmic properties. We want the form of natural log A over natural log B, where A and B are rational numbers. So I'm going to start by taking the natural log of both sides. Why are we using the natural log? Because it is easier. It is easier to write instead of log base anything else. Like you could take the log base 4 of both sides. You could. It's fine. But you're going to have to write log base 4 a bunch of times. So we're going to just use the natural log just because it's easier to do. So exponent properties, logarithmic properties, power to a power properties, we're going to rewrite this as x times the natural log 4 equals the quantity x plus 1 times the natural log of 3. Now, natural log of 4 is a number. The natural log of 3 is a number. I'm going to distribute this number into both of those. Okay? So I got x times the natural log of 4 equals x times the natural log of 3. I'm going to subtract this many x's from both sides. Now, you can either start by writing it as x times natural log 4 minus x times the natural log of 3, and then factor out the x. Or you could go straight to, oh, I have log 4 minus log 3 x's, right? Because you have this many x's subtracting this many x's. You can subtract the numbers. Think about it as 4. 4x minus 3x is 4 minus 3x's. Okay. That equals the natural log of 3. I'm going to finish off by dividing by log 4 minus log 3. Probably before I'm going to do that, I could use a log property to rewrite log 4 minus log 3 as log 4/3, right? If we're subtracting, it's the same as dividing. I will finish off by solving for x by by dividing both sides by log 4/3. Okay, I get log 3 over log 4/3, and like I'll show you, it's beautiful to see 4 to the x intersecting with the graph of 3 to the x plus 1. They intersect there at 3.819. I'm thinking that the natural log of 3 divided by the natural log of 4/3 is 3.819. Bam! This intersection is not the easiest to see. Let's zoom in on the x-axis. There you go. Yep, 3.819. It's exactly 3.81884167931. This is the answer we're looking for. This is the answer you have to find. It has the understanding of like amounts of x's, log 4 minus 3 amounts of x's. These are great to practice because a lot of students really just struggle on them. Start by taking the log of both sides. You could take the log base 3, you could take the log base 2, but we are going to tell you to write the answers in the form of the natural log of A over the natural log of B. It's just a little bit easier to do using the properties. We get the following. Okay. Distributing the natural log 3, I have x natural log 3 plus 2 natural log 3. I am going to probably move this 2 up to make it the natural log of 9. I'm going to subtract this many x's from both sides. I'm going to subtract log 3 x's. Now, this is tricky. Probably what I could do is write this as log 2 squared, so log 4. Or we could actually write this as x times 2 log 2. So it's like, how many x's do I have? Well, I have 2 log 2 x's, which is log 4 x's. This is tricky, so we need to practice this, and many of you will struggle anyways. So how many x's do I have? Well, I have log 4 minus log 3 x's. Look at that, log 4 over minus log 3. It's almost like this is going to happen again. I think it's because of this 2, and it ends up being a 3 and a 4. That's why. Okay, never mind. Probably the easiest thing to do for this question is to rewrite this as 4 to the x. We know 2 to the 2x can be written as 2 to the 2 to the x. Write it as 4 to the x. Boom. Solving for x, I'm going to rewrite this as log 4/3. I'm going to divide, giving me log 9 divided by log 4/3. This is what we want. A is 9, B is 4/3. We got 3 to the x plus 2. We got 4 to the x. Got log 9. We got to go all the way to 7. Means my y's are going to have to go really high because this is an exponential growth function. There it is. 7.638 is when those two are going to intersect. Fun. All right, let's do another one. We got 2 more of these, and then we have the big problem of the day, the log inequalities. We're going to have to do some practice ones before that. All right. Nothing I can do to kind of simplify this. You could rewrite this, honestly, as 2 to the 3x plus 2 to the, times 2 to the 5th. I mean, like, maybe this is like the way to go. Maybe this is the way to go. I'm just trying this out. Log properties. I don't know if it's any easier. Probably what I'm doing with this 2 to the 3x is writing it as 8 to the x. Just like simplify it. That way you don't have to mess around with too many numbers. I have x log 8 plus log 32 equals x log 5 plus log 25. I'm going to subtract x log 5s from both sides. So I have x log 8 minus log 5. I have log 8 minus log 5 x's. I have log 25 minus log 32 natural logs. I end up with my answer log 25 over 32 over log 8 over 5. How do I get that? I divided both sides by log 8 over 5 after simplifying this. I simplified this to be log 25 over 32. I don't know if that's easier than the other way to do it. Let's do it the other way. 25. Let's just write the answer down on the bottom and see if the other way is better, which is just like before simplifying, take the log of both sides. Great thing about these exponential problems, and also a curse about these exponential problems, is there's multiple ways to do everything. Yeah, I think it's actually harder if you take the natural log of both sides. Let's see. I'm going to move the 3x plus 5 down. I have the natural log of 2. I'm going to move the x plus 2 down. I have the natural log of 5. I'm going to distribute everything. I have 3 times x times natural log 2 plus 5 times the natural log of 2. I have x times the natural log of 5 plus 2 times the natural log of 5. It's like it's kind of showing up all of those steps that I did, just differently. Here I have x 3 ln 2, which is the same as x ln 8 if you use the exponent property. Here I have ln 25. Here, x ln 5 can't be simplified. Here, this is ln, oh, wait, my bad, 2 to the 5th, 2 to the 5th, 2 to the 5th, 2, 4, 8, 16, 32. Here, ln 25. So you end up kind of getting the same thing, but you got to know how to deal with it. Subtracting ln 5x's from ln 8x's, I have ln 8 minus ln 5x's. Again, you could subtract it and then factor out the x to kind of see that. Here, I'll have ln 25 minus ln 32. I don't know which one's easier. I think they're probably the same. We get that. Let's go to the videotape. 2 to the 3x plus 5 equals 5 to the x plus 2. They intersect, not at a crazy value. They intersect at 0. That's not right. No, that's not right. That they don't intersect at 0. They don't intersect at 0. This is just like a y-intercept of the blue one. They intersect right here at negative 5.25, which I will find is the same as log 25 over 32 over log 8/5. Bam! Okay. Up to you. I'm going to do this one kind of the simplification method first, where I'm going to write this as 5 to the x times 5 to the negative first. I'm going to write this as 3 to the 2x times 3 to the first. I'm going to write this as 5 to the x divided by, or times 1 over 5. I'm going to write this as 9 to the x times 3. I'm going to multiply by 5 on both sides to get 15. Okay, multiplied both sides by 5. I got 3 to the first times 5. I got 15. I don't know. I think maybe this is my new way to go. I haven't done these problems like this in a while, so I'm kind of remembering different ways to. Well, I'm kind of discovering different ways to do them because I haven't done them. Moving the x down, rewriting this as a sum, moving the x down. Subtracting this many x's from both sides. I have log 5 minus log 9 x's on this left side. I have log 15. I'm going to divide. This is the log of 5/9. I got log 5 divided by log of 5/9. I kind of like that. Kind of like that. Kind of like doing that a little bit better. It's just maybe easier. All right, 5 to the x minus 1. 3 to the 2x plus 1 intersects at negative 4.607. I don't think that's where they intersect. I'm going to have to really kind of zoom in here. Going to have to go. Well, let's see where they're supposed to intersect. Log 5 over log 5/9. Negative, what? What did I do? All right, let's find our mistake. I made a mistake. Five to the x times 5 to the negative first. That looks good. 5 to the x minus 1. 3 to the 2x times 3 to the first. 3 squared to the x, 9 to the x. Multiply by 5, 15. Natural log both sides. Natural log 9 to the x plus natural log 15. Bring the x down. Subtract x natural log 9 from both sides. I have natural log 5 minus the natural log 9 of x's. Yo, this is a classic student error. 15 turned into 5 magically. That's so funny. So funny. There it is. Negative 4.607. All right, to my favorite / new favorite questions. These are really doozies. We'll be right back. All right. Here's the key, guys. We're trying to help you out here. First of all, let me say, if I have this equation, this inequality, you take the log base 2 of both sides, you're going to get the right answer. X has to be less than 3. Okay? Like if 2 to the x has to be less than 8, x has to be less than 3. If you are the ones who like to move x onto the other side and you like to write x log base 2 of 8, you kind of like roll things around. If this is an inequality, you're wrong. If you move the x to the other side, you're going to have to flip the inequality. Just be careful out there, okay, with inequalities and logs. We're trying to tell you about inverses, keeping everything in line. I think it'll help you in the long run getting the answer, okay? But now, these questions are doozies. Here's why. We have a situation where we have a logarithmic inequality, all right? When is this log less than 0? Now, the first things first, I'm going to rewrite this as a quotient. Cool. Everything seems good right now. Seems like I just need to pay attention to the inside, which I do, okay? Remembering from rational functions, we can do a sign analysis of this if everything was factored. This is very important because, remember, we have to plug in positive values into log functions. So I'm going to create a domain sign analysis where I look at my values -4, -3, as well as 5. These are all of my zeros of my rational function inside the logarithm. I'm going to look at my signs around these zeros, just like if I was solving a rational function inequality. And this is our domain sign analysis. So I'm going to plug in 6, and I get a negative, positive, positive, get a negative. We can see by the multiplicities, the signs will change. Immediately, this is not my answer. We know that these are the values of x that we could plug in into the original equation, the original equality. I cannot plug in anything between -4 and -3. I cannot plug in anything greater than 5. Okay, cool. Well, now let's get to the heart of the matter, which is solving this inequality. Like, how do I solve this inequality when there's the log less than 0? Well, you can see after taking e to the power of both sides, it will be when minus x plus 5 over x plus 4 times x plus 3 is less than 1. Okay? Now, this is a rational inequality like we did last unit, where what we want to do is get everything onto one side and have it an inequality less than 0. So I got to leave some space here because we need another number line eventually. So I'm going to write this as negative x plus 5 over x plus 4, x plus 3. Minus 1 is less than 0. Okay? Now, what do we do here? Well, we want to combine these two to be one common denominator, one rational function. So what I'm going to do is multiply this minus 1 by the denominator x plus 4, x plus 3. Okay. Now, I'm going to have to distribute things, and I'm going to have to make sure I subtract everything, which a lot of you still make mistakes on. I got minus x squared, I got minus 7x, and I got minus 12. This is all over the x plus 4, x plus 3. When is this less than 0? I'm going to combine my numerator. So I got a negative x squared I have negative x plus negative 7x, which is negative 8x. I have positive 5 minus 12, which is minus 7. I will factor out a negative 1. I will factor the x squared plus 8x plus 7, giving me negative 1, x plus 7, x plus 1. Giving me a new rational function, a new set of inequalities. This is now something that I'm going to put on top of this or below this inequality. It still has negative 4 and negative 3. That's great. So I have a domain, and this is my inequality. But I now have negative 7 and negative 1. Cool. I will plug in test points like positive 5, positive, 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 positive times this negative 1 makes this negative. I get negatives here. I'm going to change signs everywhere. We don't have any holes. We don't have any multiplicity concerns. So here's my answers. Now, we are figuring out when the inequality, when this rational function is less than 0. So for my inequality, I'm looking for negative values. We need the intervals that can be plugged into the original equation, can be plugged into logs, but will produce negative values when we do that. Here is my answer. Negative 7, negative infinity to negative is 7, so x is less than negative infinity. And negative 1 to 5. It's beautiful. I'm going to show you the answer on Wolfram, like that we got the right answer because they just solve it. It's kind of tough to see graphically because the graphs kind of just like disappear when it has a horizontal, it has like a vertical asymptote. They just kind of like go straight down. But here is like the graph of log x minus 5. And what we could see is like from negative 1 to 5. It's like, well, what do you mean to 5? It looks like it goes on forever. Well, eventually the graph just like stops and you can't plug in values to the right of 5. It's probably better if I like zoom in on the x-axis. See, like you're not able to plug in values to the right of 5. This is the idea behind the domain. So like the graph does not continue on past 5. So we have this negative 1 till the graph ceases to exist. But over here on the other side, we have this negative 7 where we can plug in positive values, but we get negative results. It's just like such a great, intense question. And so like this is good. I actually can see it. I don't need to plug it into Wolfram. Like there's my intervals where we're paying attention to both the domain and then we're solving the inequality. What a great question. Okay, so this guy, ready? We need 2 different sets of sign analysis. One that's paying attention to the domain and then one that's going to like solve the inequality. So get ready to produce both of these sign analysis. So we start by rewriting this using the log property, and I'm going to go ahead and just factor. Ooh, does this work out? Okay. First things first, I can't plug in -2 and 3, but I could kind of simplify this. I don't want to, but I could. So this is great. Like I can't plug in -3. -3 is an undefined, but it ends up being a location of a hole, which means we're not going to change signs there. If you looked at really -2 as being your only thing to worry about, we'd have positives to the right of -2, and we'd have negatives to the left, including to the left and right of -3. But we can't plug in -3 because -3 is the location of a hole. Okay, there's my domain. Now for the inequality, it's probably easiest if we go off of the simplified version, paying attention to like don't plug in -3. So I'm going to take e to the power of both sides, and I get 1 over x plus 2 is less than 1. This is actually easier. I get 1 over x plus 2 minus 1 has to be less than 0. I will write 1 over x plus 2, write this as x plus 2 over x plus 2, minus x plus 2 over x plus 2 has to be less than 0. Get 1 minus x minus 2 has to be over x plus 2, has to be less than 0. 1 minus 2 is minus 1, so I get negative x minus 1 over x plus 2 has to be less than 0. I'm going to factor out a negative 1. I get x plus 1 over x plus 2 has to be less than 0. So for this guy, I have this inequality -1. First of all, the domain, we only have to plug in positive values to the right of -2. For the inequality, I got this -1 and -2. So I got to make sure things are aligned. So I got this -2 already, but I also have this -1. Oh, this is great. If I plugged in stuff that is to the right of -1, like 0, I get positive, but times -1. So this is a negative. If I actually wish this inequality was going in the other direction for this question. We will change signs. Now, we are looking at when the inequality is negative, but the domain is positive. My only answer is x is bigger than 1. The great answer, the great question might have been to look when it's greater than 0. But it's not. You can just like not pay attention to the domain. The stop questions, this is the best. We'll have one of these like in our practice. We'll have one of these on our tests just for fun, really. So let's double check, and then we're done. Log x plus 3, log x squared plus 5x plus 6. When is it less than 0? For x is greater than -1. You can kind of see that you're not allowed to plug in anything to the left of -2. The graph has like a vertical asymptote at -2. So yeah, it's good. It's just good. You're like paying attention to the domain, and then you pay attention to the inequality. When do they both, like if you just did the inequality part, you'd probably say negative infinity to -2 and -1 to infinity. But you need to not pay attention to this portion because it is when there is no graph because of the domain. You'd be plugging in negatives into the logs. That's bad. All right, so good questions, some tricky questions. Demand practice. Don't just copy this down. If you did, you're not ready for your quiz or your test. All right, we'll see you out there.